Hi, welcome to the Calculus 3 lecture series. And we are in the unit Vectors and the Geometry of Space. And for this video, we're going to talk about lecture number 4. And we're going to talk about another very important vector operation. We call this the cross product here. All right. So for this lecture, we're going to divide this lecture into two videos again, because each one probably will last more than 30 minutes. And don't want the whole video last too long here. Okay, so let's just go to our worksheets, and let's start to take a look. How do we do it? All right. So the first things here, let's take a look. What is the definition of the cross product? All right, so now I'm going to, let's try to, kind of the review what we did before. See here. So what we had in the lecture number 3 is the dot product. So what is the differences between the dot product and the cross product here? Okay, so the dot product, if you still remember, so this is a brief review about what is the dot product here, right? So we say if we have two vectors, so it doesn't matter 2 or 3. And so if I have vector A and the vector B here, okay, and what is the A dot B here? We said A dot B will give us a scalar, will give us a constant. So you just use the first elements times the first elements, right? So A1 times B1 plus A2 times B2 plus A3 times B3, right? This is what we define the dot product here. Okay, so the dot product, the result is a scalar, okay? So here, this is we call this the cross product. So if I have the two vectors A and B, so the cross product here, this is the notation we use. So it turns out the cross product, the end result is what? The cross product, the end result is a vector here, okay? And this vector is a very special vector. So this vectors here is the vector. So whatever the resulting vectors here will be a vector perpendicular to the both A and B. So if from this graph you can see, so you have A and B here, then these vectors here, see here, the A cross B, right? So this is we call this the cross product. And so let's just get familiar with the formula first, then later we'll talk about what is the right-hand rules here. So this is a dot product, this is a cross product formula. It looks pretty complicated to remember, right? So the easier way, instead of remember the formula, this is what I will tell you, I will show you guys how to do it. So you put it into a matrix here. So here, this you put the I, and this is your J, and this is your K, right? So this is your basic vectors. Then you put A's here, so you say A1, A2, A3. Then you put a B here, it's B1, B2, B3, all right? And then in order to do that, take the first two rows, columns out here. Okay, so here. Okay, so the first two columns, so it's I and the J out. So this is A1, A2, then B1, B2, okay? So take these two columns out. Okay, now you do the cross product here. So let's start here. Okay, so let's do here, the first way, you go this one. So the first one's here, right? So this will be let me write it. So it's A2B3I. Okay, then you continue, go here. Then it's a plus A3B1J. Then you do like this. Then it's a plus A1, B2, K. All right. After you did that, and then we go another way. So I go this way, right? So when you go this way, so you minus. I think here, so this is plus A1, B2. So it's going to disappear. So A1, B2. Okay, so that's good. Okay, so minus here, right? So this is A2, B1, K. All right. Then you go this way. So you minus A3, B2, I. Then you minus this way. So, excuse me. So this one here is A1, B3, what? J's here, right? Okay. And now here, let's try to combine the similar term. All right. So let's say the I and I combined, I and I. All right. So what you have I and I's here. So it will be A2, B3 minus A3, B2, I. Correct? Okay, now you combine the J. So this is a J, this is a J's, right? Okay, so you combine the J, so it's plus A3, B1 minus A1, B3, right? So this is a J. Okay, now the last one, you combine the K here, right? So K. So now you can say here the K is a plus A1, B2 minus A2, B1, K. See here. That's why if you want to include, write into, so this is IJ case, right? So if you write into like the vector form, so this will be A2, B3 minus A3, B2. See here, A2, B3 minus A3, B2. Then the second one is A3, B1 minus A1, B3. Then this one is A1, B2 minus A2, B1. Okay, so that is how this formula you can simplify, not simplify, you can remember this way is easier, kind of like find the determinant of the matrix you learned before, all right? So this is a very mechanical way how to find it. If they give you two vectors, how do you find the cross product? So what the most important part is, what is this cross product, right? So we know this cross product ended with a vector. So these vectors here, right? Like we said, this is very important. So the cross product, right? So they build up vectors, right? So that vector will be perpendicular. So for example, like if you look at these screens, right? So if I have A and B, okay, so the cross product, that means I produce a vector is kind of you directly, the perpendicular to the screens here, right? So that's what is this vector mean. The vector A cross B is the vector, directly is perpendicular to both. So like if A and B in the XY plane, then the A and the A cross B will be on the Z, right? So that's why that one is perpendicular to both. So what is this right-hand rules here? So the right-hand rules is like a very handy rules to use, because you said, okay, A cross B, they're going to produce a vector which is perpendicular to both A and B. Then you might ask, you said, okay, now why this vector is not this vector? It's go downward, right? So how do I know which vectors go where? So this is what we call it, the right-hand rule. So you put your right hand out, right? And then you use your fingertips here toward the whatever the first vector. So it's A cross B, right? So you put your fingertip, right, toward the A, then cross B. That means you turn your finger to the B direction, right? Then to see where is your thumb heading, right? So if your thumb, point up, that means this cross product vector is go up. If your thumb, when you put it the correct ways here, so like this one's here, if you put a B over A here, right? Then what happens here? Then it will be the vector, the A cross, so the B, so like these vectors here will be the B cross A's, right? So that means you put the fingertips here and then you cross to A. So your thumb has no choice. It will go point downward here. All right, so that's what we call it is the, the right-hand rules here. So make sure right now we understand, what is the, how do I physically calculate the cross product, and then, what is a cross product means here. All right, so then the next things here, is several very important properties here, right? So let's see what is the keyword here. So the first things here, we said A cross B is orthogonal. That means it's perpendicular to both A and B here. Then the second ones here, they said A cross B is AB sine theta. This is the one we're going to show you how to prove it, okay? And then in here, we said A cross B is going to be the negative B cross A, right? So because they're going to go to the different directions here. All right, so the next ones here is if you times a constant, so it will just be times constant and cross product. So that's kind of a trivial here. And then we do have the distributive property work. So if you add the two vectors together, then your cross product will be equal to what? Will be equal to your cross product, then add them together, okay? So the same ways here, if you have, the A add B in the front, so in here, the similar like the distributive properties, right? So it's just like this. So it's A cross B plus B cross C. So this one's here is very important. We're not going to prove it. If you want to, you can go to proof by using our definition. So it's A cross B cross C, right? So that means the B cross C first, right? Name the A cross, the B cross C. So it will be equal to A dot product C, the B, minus A dot product B, the C here. So for these ones here, like we said, we're not going to prove it. And we're going to, if you like, you can prove it by using give it the three vectors, right? A1, A2, A3, B1, B2, B3, C1, C2, C3, and then figure out you will get it. Then the remaining here is if you use the standard basis and what is the vector. So all these six, it can be easily verified by using the what? By using the right hand rule, right? Right hand rule. So you can kind of try to play with it to see where is your thumb point, right? Then you can see why is sometimes negative J, negative K here. And then, okay, so the last thing here, we're going to talk about the two theories here before we do some practice. So the theory number one here, it will tell you this is A cross B is equal to AB sine theta. If you still remember, right? So from the dot product, we have a very similar rules here. Don't get confused, right? So if you remember, we said A dot B is equal to what? The length of the A, length of the B, and the what here is a cosine theta here. So it's very similar. So to cross product, they said A cross product, the length of the A cross product will be equal to the AB sine theta. Then the next series here, they tell you for the two non-zero vectors, if they are parallel, then if and only if A cross B will be equal to the zero vector. This is a vector, right? So this is a zero vector. The reason why is because if they parallel, right? So if they parallel, so what's that mean? That means the theta is equal to what? theta is equal to 0, right? Because they parallel, right? So that's why. So the parallel, that means the theta equal to 0, and then you use the, you use the previous theory, then you know the length of A cross B is 0. That means it come out is 0 vector. This is also a very similar, like in the cross product here, right? So in the cross product, I'm sorry, in the dot product here. So we said if A and B and are what? Are perpendicular, right? So it's not a parallel. If A and B are perpendicular, then what happened? A dot B is equal to 0 because the same thing, because they are perpendicular, the theta here is 90 degrees. So that's why the A dot B is equal to 0. So this is the similar, this is the similar property like a dot product. The reason why is you still apply to this series, right? So when theta equal to 0, then you say the A cross B, the length equal to 0. So what could be the length equal to 0? You have to have a 0 vectors, right? So the 0 vector, so that's why you give the length equal to 0. That's why the A cross B will be equal to the 0 vector. Okay, so now I'm going to prove, because we did prove the A dot B equal to the AB and cosine theta, right? So the same things here, and we're not going to prove much, but this is one of the things we want to prove, is because it's very similar and very important things here, all right? Okay, so now let's try to prove these ones here. Okay, so we want to prove the A dot B, A cross B to the length, right? So A cross B, the length here. Okay, so let's do the length squares, right? So by using the definitions here, okay, so if you remember, right? So A cross B, we have in the previous is like A3, A2 minus B3, right? So these numbers here will be equal to what? This is A2, B3, right? A2B3 minus A3B2 to the square plus A3B1 minus A1B3 to the square plus A1B2 minus A2B1 to the squares, right? So those numbers here, remember, this is what the, this is what the A cross B is, right? The A cross B, each components, right? So the length of that square will just be like the similar like A1 square plus A2 square plus A3 square, right? So here, okay, so now I'm going to FOIL everything here. So this is A2 square, B3 square, okay? Then minus 2, A2, A3, B2, B3, plus A3 square, B2 square. It's just use A plus B square, is A square plus 2AB plus B squares, right? Okay, so then plus, okay, so this is the first terms, right? So this is the first term, all right? So now do the second term, so the plus here. So this is A3 square, B1 square, minus 2A1, A3, B1, B3, plus A1 square, B3 square. Right, then plus. So what is this one? This is the second term. I just FOIL. It's pure algebra, right? Okay, now the last terms here is just A1 square, B2 square, minus 2A1, A2, B1, B2, plus A2, B2 square. All right. So this is just what? This is just the third terms, right? So it's just a simple algebra FOILs here. Okay, so now I'm going to combine here, right? Okay, so I'm going to combine. I'm going to combine A1 square, B1 squares, right? So I'm going to combine here, okay? So I'm going to combine these few terms. I'm going to combine this one, this one, this one, this one, this one, this one, all right? So this one here says A square, B3 squares, right? So all these yellow terms I can combine with is A1 square plus A2 square plus A3 square times B1 square plus B2 square plus B3 square, right? So I have how many yellow terms? 1, 2, 3, 4, 5, 6, right? So I have 6 yellow terms. So now I combine, kind of factor that, right? So in here. Okay, so now for the remainings, right? So A1, B1s, right? And A2, B2. So if I combine all the remaining terms, going to give me this ones here. So will give me A1, B1 plus A2, B2 plus A3, B3, the whole thing square. Right, so that means in here, I'm going to have this term, this term, this term, the whole thing square. So that means if you FOIL it, it will give you so will give you these green terms here. All right, okay, so now let's take a look at these ones here. So A1 square, A2 square, A3 square. What is this one? This is the length A square, right? B1, B2, B3. What is this ones here? This is the B square. Okay, take a look at A1, B1, A2, B2, A3, B3. Okay, so A is equal to the A1, A2, A3. B is equal to the B1, B2, B3. So A1, A1, B1, A2, B2, A3, B3. Oh my gosh, what is that? That is A dot B, right? So here, this is A dot B, what? To the square, right? Okay, so now this is the beauty of it. This is A square, B square. So what is A dot B? We just reviewed, we said A dot B is A, B, and what? Cosine theta, right? So now these ones here will just be A, B, cosine theta square, right? Okay, so now in here, this is the A square, B square minus A square, B square, and the cosine square theta. Ha, now I see I have A square, B square. Okay, so this one, can I factor that out? Oh yes, so when I factor out, this will be 1 minus cosine square theta. What is cosine square? 1 minus cosine square theta. Is sine square theta, right? So that's why I know A cross B to the square equal to the sine A square, B square, sine square theta, right? Okay, so now that's why we take the square roots both sides. So we got A cross B here, right? So A cross B is equal to the A, B, and sine theta. Of course, here theta here is from 0 to the pi. So because sine is greater than 0, right? So because we know y is since the square roots of the sine square theta equal to theta is only when the what? When theta is from 0 to what? 0 to pi is here. All right. Okay. So that is, all right. So that is how do we prove this theory? And this theory, and we're going to, in the second video, this theory going to tell us something very important. Also, we have the application for this theory. Okay. So now let's take a look. Let's try to do some practice here, all right? So the first thing here, let's say find A cross B. So remember what I told you? How do I do that? Okay, so you put the I, J, case here, right? So you say 4, -1, 3, right? Then you have 1, 6, 2. Okay, so now let's see, do we still remember how do we do that? So we go here. So what is I? -2I, right? So -2I, then here, oh, sorry. Okay, so I try to, did not even, okay, so here, so this is ij, so I move 4, -1, 1, 6, right? Okay, so the first one is here is -2i. Okay, so what is my next here? Next is here, right? So let's see, is what is plus 3j's here. Then what is here? Okay, then plus 24 what k's, right? Right, so you go to, let me change this to the same color so it will be easier to color coding that. So this is -2i. Okay, now I'm going the different directions here. So I'm going to minus here, be careful, right? So I'm going to minus, so what is here is -k. Then here, minus, so -k, so this is what? Let's, okay, so this is 18i. Then this one is what? AJ's here, right? Okay, so now let's be careful here. So this is -2i plus 3j plus 24k plus k minus 18i minus AJ's here. I hope that my positive and negative sign is correct. All right, so now let's take a look at the combined I. Boom, boom. So what is my i's here? So I is -20i. What is j's here? Combined a similar term for j. So here's j. So it's what is here? It's a -5j. Then the k is the last one. So it's 25k, right? So the k is here, so it's 25k. All right, so this is our answer. So the A cross B will give us a vector. This vector is -20, -5, and 25. Okay, so now, okay, number 2, sometime, always, or never. So A cross B is equal to the B cross A. As we discussed right a while ago, we said, if you go back to the right-hand rules here, so we say A cross B is going to this way, and the B cross A is going to the opposite ways here, right? So let's say this is always true or never true or sometimes true. So this one's here, the answer is sometime. The reason is sometime. That is, if they are, if A cross B is not equal to the 0 vector, then the A cross B is not going to equal to the B cross A because they're going to go to the opposite directions, right? So they go to the opposite direction. So in general, it's not true. But, but if the A cross B is equal to the 0 vector, that means it's the 0 vector, that means then the B cross A is also is the 0 vector. So that's why this answer is sometimes, all right? So the sometimes, so if the A and the B are parallel, so if A and B are parallel, that would be one situation. So this is a situation sometimes is like A parallel to the B, because I know if the parallel, then the cross product will be equal to 0 vectors, right? So this is one situation. Or is like one of the vector is 0 vector, so it's A equal to the 0 vector, or B equal to the 0 vector. So under those 3 situations, this were true. So that's why we say sometimes is true. All right, it's not always. Okay, number 3 is here, right? So the number 3 is here. It said, okay, A is equal to the 250, B equal to 430. Does A cross B point upward or downward, right? So if you use the right-hand rule, you can have a 2 ways to do it. Like I said, a right-hand rule, you know, put your right hand. So because we are looking for A cross B, right? So have your fingertips point at A, then A cross B, then when you use your finger kind of cross, right? So kind of the cross to the, that means you curve your finger to your thumb. Then you will find out your thumb, what happened to your thumb. Your thumb going to point downward here. So the answer is downward. So if you want to use the right-hand rule, or if you don't want to use the right-hand rule, you can just directly do the cross product, right? So you can just do the A cross B here. Then use what we did here, the A cross B. The answers here, I already did that. So you will get a 0, 0, negative 14. Right, so this is the negative 14k. So k is the z-axis, right? So it's negative. That's why it's going down. So that's we could say it's going downward here. All right. Okay, so if you use the right-hand rule, it's a lot faster, right? Okay. So now the next one's here. Let's take a look here. So we say for any vector A and the B here. So what happened to the A cross B plus the B cross A? So I know the A cross B, right? So if you change the B cross A, right? So because A cross B, if A cross B, the vectors go upward, then we know the B cross A, the vector is always go downward, right? So they go to the opposite directions here. That's why we know the A cross B plus B cross A. What happens here is always going to give you a 0 vector, right? So this is what we call it 0 vectors here, okay? And now the part B say for any 3-dimensional vector A, what is the A cross A? Oh, the A cross A, we know what happened here. Because A and the A itself, what is the angle theta between the A and the A? Pi is 0. So that's why we say A cross A is equal to what? It's a 0, right? So it's a 0 vector again, right? So this is a 0 vector. Okay, so this is a little bit different than the dot product, right? So we said the dot product like A dot A. So what is that? Is the length of the A square, right? But A cross A, you cannot find a perpendicular vector because both of these vectors belong to the same vector. So it's 0 vectors here. Okay, so now number 5 here. They say use the cross product property to evaluate that. So right now, what do we have here? We have this standard base, IJK. So we can use our right-hand rules to do that. So the first thing here, we can say that we use distributive properties, right? So this will be equal to 8, right? So 2 times 4 is 8. Then you have I cross J, correct? If I cross J, then plus 6, you have I cross K. So if you use your, if you use your right-hand rule, I cross J will be what? I cross J, these numbers here will be vector what? Vector K here. So that's why we'll give you a K. Okay, so then I cross K here. So the I cross k, if you use your right-hand rules, will give you negative j. So this is plus 6 times negative j. So it's go to the negative sign of the y-axis, right? So this will be the ak minus 6j. So the cross product here, or you can write this is 0, negative 6, 8. Okay? So the number 6, okay, this is one of the very commonly used things for the cross product. Basically, you just want to find an orthogonal product. So you want to find a product, you want to find a vector, which one is orthogonal to both. So if they say like that, that means I need to find a cross product because I know the cross product yield a vector which is perpendicular to both. So perpendicular, that means orthogonal. So correct? Okay, so now we can do the same things here. You do this is I, J, K, right? So you put it here, then the first vector is 2, negative 3, 1. Then what here is 1, 1, 2. Then in order to do that, you move the first 2 columns out, right? And then you do like the go right, 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 right? And then you minus, you go left, 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 right? So in here, you know, if you go through that, I got the answers here. I'm not going to repeat that. So I think it's very mechanical. You should be able to do that. This is negative 7i minus 3j plus 5k. Okay, so that means that this vector, okay, so this vector is perpendicular to both this one and this one here. Okay, so now, and this one is pretty important, all right? So this one's here, they say, is this is true or false? The A cross B cross B, B cross C is equal to A cross B cross C. Okay, if you kind of, I don't know, you remember dot product, right? So we say A dot B dot C, okay? So remember this, in the dot product, what do we say here? This is not exist. Correct? The properties here, you need a very clear mind setting, right? Because the A dot B, this is a scalar, right? So this is a scalar. And A cannot, vector cannot dot product scalar. So that's why it's not exist for the dot product. Okay, so for the cross product, it does exist, but they do not have the property. It's like if the product, like the B plot C, the product dot, you know, the cross product B and C first, then A cross product is does not equal to your cross product A and B first, then cross product C, right? So because why? Because I think, okay, so here we say, this is what the formulas here we have here, all right? So it's not equal, you cannot just moving around your parentheses here. So, and that's why this one is not the truth here, right? So this answer here is false. Okay, so if you want to check it, so you can, if you can find it, so for example, see here, okay, so for example, you know, I can find, like I said, I can disprove that. So I can say letter A equal to the 1, 2, 3, all right, B is equal to the 4, 5, 6, and the C, and the C here is equal to the 7, 8, 9 here, okay? Okay, so the C here is what, 7, 8, 9. Okay, so you just give us any 3 vectors here, right? So if you just do the, so if I did this, so I do the A cross B cross C, and the answer is negative 24, negative 6, and 12. But if you A cross B first, and then cross C, I have this is 78 and 6 and negative 6, 6. That's why this is not equal to. That's why we have the formula from the previous slide here. All right. Okay. So that's it for the, for the first part of the cross product. Then we still have a few more problems. So we're going to take a look at the cross product applications here. And remember the dot product, we have some geometry applications, we have a physics application. So the same for the cross product, we're going to have some of the geometry application and the physics application as well. Okay, so that will be covered in the second part of the video for this lectures. All right. Okay, so I'm going to stop here, and you guys have a nice day, and don't forget, we have the second video to complete this lecture series. Okay. Okay, talk to you, and bye.